Okay, so let's see, this is the thing you're talking about right here, right?
It was, yeah, those are the cost revenue ones. Yes.
Exactly. Okay, so was it a practice problem or a your turn or your
It's
try?
a you try one. I did the media example, the one
Okay.
13, and then I'm stuck on 14.
Okay, great. Let's go ahead and go through 14 then. Okay, so February is Charlie's Chocolate Shop. So during the week before Valentine's, Charlie advertises chocolate will be selling for $1.80 a piece instead of the usual $2 a piece. Fixed costs run $450 a week. He can estimate each chocolate costs 60 cents to produce. Charlie estimates he can produce up to 3,000 chocolates in 1 week. Okay, so let's back up for just a moment up to these formulas up here, okay?
Okay.
So when let me get the pen going here. Pencil, there we go. Okay, so the cost function, the way you determine cost is it comes in basically two pieces. Cost is based on how many of them you make plus a fixed cost. So there's some sort of dollar amount, a per item cost for each item that you make, and then there's some fixed value that it's your startup cost. That's one way of thinking about it. And then revenue is pretty straightforward. Revenue is just R of X is always going to be some dollar amount. In other words, how much you're charging per your item times the number of items you make.
Okay.
Okay. So now if we come down here, we got to dissect out of this those numbers. Right. Exactly. Okay. So let's go ahead and see what we're going to do. So he's going to be selling them for $1.80 a piece. Okay. So that has to do with his revenue. So if we're thinking about his revenue function, R of X, you know what, if you don't mind, for whatever reason, my little graphics pad freaks out when between this PDF viewer and when I'm sharing online. So I'm going to go back over to this thing, which doesn't freak out quite as bad. So we're going to have to switch back and forth a bit, but it'll work.
Okay.
All right, so here we go. So we got R of X is going to be equal to, and it's some dollar amount times the number of them we make, okay? So if we look here, the dollar amount, that's the $1.80. In other words, you make $1.80 off of every one of them you sell.
Okay.
All right? So for example, if you sold one of them, you'd make $1.80.
Right.
If you sold two of them, you're going to make $3.60.
60 cents.
Right? And if you sold four of them, you'd be 4 times $1.80, right?
Right.
If you sold X of them, you're going to be X times $1.80. And so that's right. So that's where this comes from. The 1.80 times X, that's our revenue function. That's how much money we're bringing in. What do you think, Andy? Is that making sense?
Yes.
Cool. All right. So let's go tackle cost now. Okay. So we've got revenue. All right. So now for cost, the fixed cost, they gave us that. The fixed cost, that's the amount we don't have any control over. Yeah, that doesn't change. That's $4.50 a week, okay? So fortunately they're asking not monthly, but they're going to go for weekly here in all these questions, which is good. That would be mean of them if they switched over to monthly. Well, you got to watch it because a lot of authors do crazy things like that. All right, so our cost function, C of X, that's going to be equal to
450.
Yeah, well, this is what you could call right here. This is the variable cost. And what that is that changes depends on how many of them you actually manufacture, and that's going to be plus in our case the 450.
Okay, I did C of N equals 450.
Yeah, well,
so that's wrong.
No, because see, then you're just doing the fixed cost, and you're saying it doesn't cost them anything to make chocolate.
Okay.
And you go, nah, that ain't right. It costs them a little bit. So he comes back over here, and what does he say? He says he estimates that it's going to cost them about 60 cents each to produce them. So that's the variable cost. That's the part right here. That's this dollar.
So that's the $X.
Yes, right. So that's the 0.60X plus 450, and that's going to get you your cost function.
So that's 0.60X plus 450.
Making sense?
Yes.
Okay. All right. Now, capitalism 101. Profit is equal to revenue minus cost. So you take what you make and subtract from that what you spent, and that's your profit.
Right. Okay.
So what we got to do now is we got to come in here and go, okay, 1.80x minus, and got to put this one in parentheses. Got to be careful here because we have to distribute that negative. So it's 0.60x plus 450. What do you think?
Can we go over that one again?
Sure, of course. Okay, so let me change colors here. So we're going to do a little color coding, might help make things a little clearer. Where's my color palette? There it is. Okay. So this is the C of X, right?
Right.
That's the C of X right there, what's in the red box. Everything that's in a red box is C of X.
Yeah.
Okay. The green box.
Okay, yeah.
The green box, that's our R of X. Everything that's in a green box is what?
The R of X.
R of X, okay? So all I did is I took this R of X right here, I dumped it out and put in its place the 1.80x. And the same thing here, the C of X, I dumped out that box and put in its place what its definition is. Better?
Yes, thank you.
Cool, all right. So now we got to clean that up a little bit, all right? So let's get a fresh sheet here. So we've got that our P of X is equal to let's see, what was that again? 1.80 minus 0.60x plus 450. All right, so one way to think about this, to get rid of those parentheses, is to think about that as being a -1 out front. And what you need to do in order to get those parentheses to go away is you need to distribute that -1. In other words, you got to put one there and you got to put one there. And so when you do that, this ends up being 1.80x minus 0.606, right? Minus 450, right? Exactly. Yeah, got to make sure everybody gets the negative. Got to be kind, sharing. Everybody gets negated. All right, so that's going to be $1.80 minus 60 cents. That's going to be what, $1.20?
Yep.
So they're making $1.20 per bar, that's pretty good. But I mean, I'm sure there's a lot of labor involved in this too, right? Labor is part of going into this profit here. So that's going to be his profit function right there. It's 100 or 1.20x minus 450. Okay, so let me go back to the book for a moment. Let's see. Yep, that's what they wanted, right? They wanted C of X. P, they have N, but we used X. You can use an X there. That's fine. Yeah, and then P of X. Better, worse, somewhere in between.
No, that's better. I was completely wrong. So
okay.
yeah.
Hey, it's all right. You know. Did you watch that little video about how to learn algebra? And they talk about that the only way you're ever going to learn algebra is by making mistakes. You actually burn.
I didn't watch the video, but
It's worth watching that one. Go back to the orientation and watch that short video. It'll give you a pep talk about algebra and realizing that making mistakes is a really good thing, actually. Okay.
I watched your orientation video. Was it in that?
We
froze. You froze.
Hang on. Give it a sec. It'll come back.
Okay.
It's coming back.
Yep. I watched your orientation video. Was that what it was?
No. It's in.
It's another link.
It's in the first assignment, I think. I think it's in how to learn algebra. It's like during when you took the assessment, the algebra, how your algebra is doing assessment.
Okay.
All right, let's go take a look at this one. So interpret the meaning of the statement P of 300 equals -90. Okay. Well, what that means is what they did is they went into the profit function and they put in that they sold 300, right?
Mm-hmm.
And so we could actually run through it, although they didn't ask us to do it. Let me just show you that real quick, okay? So they said, go figure out what P of 300 is. And P of 300 is equal to 120, or 1.20, excuse me, times 300, right? Minus 450. Okay, so get our handy dandy calculator here. Come on, little calculator, you can do it. So if we do that, and we go, okay, 1.2 times 300 minus 450, you get back negative 90.
I'm a little slower than you.
That's okay.
Yeah, negative 90.
Sweet. Okay, cool. All right, so now what they want us to do is interpret what that means. Well, remember, this is our profit function here, right? And so that says that if I sell 300 candies or 300 chocolates, right? I'm going to lose $90.
Okay. Okay.
Because you didn't sell enough to cover your cost. Does that make sense? Your cost ran more than your revenue, and so you had
got to sell more
exactly
to make the profit.
Exactly. Okay, so let's go take a look here. So now they say determine the practical domain and the practical range for P of n. Use this information to define an appropriate viewing window for the graph P of n. Sketch the graph in the calculator space provided. Okay. All right, so let's go back over to the board for the book, actually. No, stay in the book, Mike. Scroll back up, so I want to do. Okay, so because they give us some information to help us figure out the practical domain here. So during Valentine's week, he's advertising and selling a $1.80 piece instead of the usual $2. He estimates that he can produce up to 3,000 chocolates in 1 week. Okay, so they're giving us the practical domain right there. They gave us that in the problem set.
Right.
So if we come back over to here, I can do this one here. I think the pen will work good enough for this. The practical domain is going to be, well, I don't have to make any. So that would be 0 chocolates, right? Up to 3,000 chocolates. And inclusive, right? The endpoints included, so we're going to put brackets on there. If you're going to do that in inequality notation, it would be 0 was less than or equal to, I'm going to stick with X because we've been using X.
Yeah.
Or you could put N in there if you wanted to.
And then less than or equal to 3,000.
Exactly. Good job.
I'm getting better at that.
Ah, that's good.
The one video on the Desmos.
Yes.
That helped me.
Really good.
Yeah.
Good. That's good to hear. Okay, so practical range, we're going to do a little bit of work for the practical range, okay? So let's go back over to the whiteboard for a minute for the practical range. So to get the practical range, notice our domain went from 0 to 3,000, right?
Yeah.
So that gives us actually the endpoints. This is X, right? And so over here, it's going to be P, or P of X. We want to know what those values reside between. Well, to do that, we're going to need to, first of all, take the lower endpoint on the x's. In other words, let x be equal to 0. And then P of 0 is going to be equal to 1.80 times 0 minus 450. So if he sells nothing, right?
50.
If he makes no chocolates, sells nothing, he loses $450, right?
Yeah.
Bad week.
Yeah.
Okay, so what if x is equal to 3,000? Well, then that's going to be P of 3,000, right?
Yeah.
Which is equal to 1.80 times 3,000 minus 450. Okay, so let's go grab our calculator again. So 1.8 times 3,000 subtract 450. So $4,950. That's the most profit he can make.
That's what I got.
Sweet. Okay, so that's his practical range. So his practical range, if we come back over here, is that he can go from losing $450 up to making $4,950.
And those are those type of brackets, because for the practical domain, you can't go any further because you can't make -1.
Can't make any negative. Yeah, we can't make negative chocolate. No
Yeah,
anti-chocolates.
right. And then the practical range, that's because of the solution that we got from the up top. Okay, I sometimes have to talk out loud to figure it out.
That's okay. No, it's totally good, because what you're doing here is you're saying the P of X is less than or equal to 4,950. If I sell all 3,000 of my chocolates, that's how much money I make, right?
Yeah.
And that's going to be greater than or equal to negative 450, which is what happens if I sell 0 chocolates.
Yep.
So sometimes the inequality notation makes more sense because the letter that you're looking at's in the middle, and it kind of drives home what's going on with it. Okay, so they want us to go load these numbers up into the window in our calculator so we can actually see the function, okay?
Okay.
So to do that, I'm going to go into our y equals first. Clear out anything you've got in your y equals. And we're going to put in 1.80x, subtract 450. All good?
Yep.
Okay, cool. All right, now we're going to go to our window. They said use the practical domain and range to do your window settings. So we're going to go to our window. Going to make our x min 0. Going to make our x max 3,000. So in other words, I'm going to put in those endpoints that I just figured out, right?
Right. Yep.
For my domain into my x min and my x max. If you want, you can make the x scale, let's say, I don't know, say 500, so you don't have a gazillion tick marks. Otherwise, you get a bold-faced axis. But that's up to you. If you left it as 1, it's no big deal. Okay.
Okay.
All right. So then we got what? Negative 450.
Yep.
And then we've got 4,950. And again, I'm going to make the scale 500 there so that it's not bold-faced. Again, if you just left that as 1, no big deal. It's just you're going to have a really thick axis. So far, so good?
Yep.
All right, sweet. Okay, just press graph now. And that's what the graph looks like over your practical domain and your practical range. And so they want a sketch of that back onto our homework, right? So if we come back to the homework here, they want us to put a sketch in this box right here. That okay? I'm gonna do it on my whiteboard. Okay.
Okay.
Just because it'll be a little cleaner for me there. So we've got, if we go back to the calculator again, we just want to make a reasonable facsimile of that right there. Okay, so it needs to have all the salient features. So we need to show down here how it's below the axis and it comes above the axis, right? That's going to be an important feature.
Mm-hmm.
Okay, so here's my y-axis, here's my x-axis, and then here is, I'm gonna change my color here. And then so here is my function. That's my P of X right there. So that's P of X is equal to 1.80 X minus 450. And that's my X, and that's my P axis, okay? All right, so your graph should look not quite unlike, but similar to that. They want something like that, okay? But
yep.
the important thing, which is really is a good question, I'm glad they asked this. Get to the right spot here. Is they want to know what is the break-even point, and they want us to mark that on the graph above. So break-even point, that's an important concept. If you take an econ class, they're going to talk to you about that. And what break-even really means is it means that your revenue is equal to your cost. So let's come back over to the whiteboard and let's mark that on there. Let's write that down, okay? So break-even what that means is that revenue of X equals cost of X. So it means the two of those are the same, or a much better way, in a way they probably won't really want us to think about this, is that the revenue of X minus the cost function of x is equal to 0. In other words, if I move that c of x over to the left-hand side, I end up with revenue minus cost is equal to 0. But keep in mind what revenue minus cost is. That's profit. So what they're telling you is a break even. Another way of talking about break even is to say that the profit was equal to 0. So it's equivalent to say it either way. You can just say, well, revenue was equal to cost, or you can say profit is equal to 0. And either way, you found the break even point. Okay.
Yep.
And if you think about it, that makes sense. Break even means I've made just enough money to cover my costs, so I broke even.
Yep.
I'm not out anything, but I haven't made anything. But at least I'm not in loss, right?
Right. Not a negative.
Exactly. So as far as our graph goes, we know that the break even point's right there.
Yeah.
It's where our profit is equal to 0. It's where we cross the x-axis. All right, but they want to know what that point is. So to do that, we've got to solve 0 equals 1.80x minus 450. In other words, we got to set the profit function equal to 0 and then solve for x. So 450 is equal to 1.80 x, or 450 divided by 1.80 is equal to x. Andy, is that making sense? I'm going a little quick, but
no, it's fine.
It's good? Okay. All right.
Yeah.
Okay, so if we come back in here to the calculator, that's going to be 450 divided by 1.8. And so we got to make 250 chocolates to break even is what it looks like, right?
Yep. 250 chocolates to break even.
Is all good?
Yep. Word problems trip me out a little bit.
Well, if you go slow and you know, kind of wait, I think I made it. Did I make a mistake in there? Hang on, I think I got the profit function right. Yeah, that's not the right profit function, Andy. Time out.
Okay.
Time out. I just realized I made a mistake there. Hang on. Hang on a second here. I think I did a miscopy. Yeah, duh. Well, I'm glad I caught it now. Not after I finished the recording. Let's go back and fix up a few mistakes, okay? I apologize. So I just thought, wait a minute now. I thought we lost money when we made 300 chocolates. How am I breaking even at 250? That doesn't make sense. Okay. All right, so I'm going to grenade this board because this board needs to get redone. This is not right. Okay, so let's write the profit function down correctly this time. 1.20. I'm sure our studio audience was screaming at me at this point going, you dork, you wrote down the function wrong. How did you do that? Okay, so the 0 to 3,000, that's fine, but we didn't get the practical range correct because we put the wrong function in here, okay? So of 0, that's still, fortunately, no mess up there. That's still equal to 450 or negative 450. But P of 3,000 is equal to 120 times 3,000 minus 450. So can you do that for me on the calculator? Let me know what you get there.
Yes.
So for you folks watching at home, we're going to have to redo pretty much the last half of the problem. Sorry about that.
Okay, 120 times 3,000.
Right.
Minus 450.
Yes.
359,550. 359,550.
Hang on a sec. That sounds a bit big. Let me check.
Right?
That sounds like you might got an extra 0 in there.
120.
Oh, wait. No, 1.20. Did you not?
Yeah.
I'm sorry, my decimal point's not very clear there. That's my bad. Sorry about that.
I have it written down as 1.20.
Yeah, my decimal point didn't come across very good there. I was gonna say that's an awful lot.
3150.
There we go. Yeah, that makes way more sense. Okay. Okay, cool. All right. So what that means is that the practical range was 0 is less than or equal to P of X, which is less than or equal to 3150. Cool. All right. So that means if we come back now, let's go back to the book here. Then we have to redo our graph a little bit, okay? Because this number was wrong. And because we weren't making quite that much, so we got to enter in the right function, and we got to put in the right endpoints on our range. Okay.
Okay.
So back to the y equals. Let's clear that out and put in 1.2 x minus 450. We're just showing how to grow synopsis, right? I mean, making mistakes. You won't forget this problem, right?
No, I won't.
Okay. All right. So we got that. So let's go hit the window key.
And all we're doing is changing the Y max to 3150.
Got it. Exactly. Everything else is good to go. Good job. So the graph really doesn't look that much different.
No.
I mean, really don't have to change that. I mean, it's pretty much the same. It's just the number for the break even is going to come out differently. So let's do our break even again. So break even is where P of X is going to be equal to 0. So that says that 0 is equal to 1.20x minus 450, or 450 is equal to 1.20x, or 450 divided by
1.20.
Yes, 1.20 is equal to x.
$375.
Yeah, it makes more sense.
$375.
Yeah, because 300 we were still negative 90. Remember when we looked at that earlier? So yeah, that's much better. Okay, so x is equal to 375. So what that tells me is that at 375 I break even. So all of this, don't ignore that.
Okay.
But over here, we're good to go because we know now that if I make 375 chocolates, my profit will be equal to 0. In other words, that's the ordered pair.
375.0.
Yeah, for the break-even point.
Nice.
Yeah. Sorry about that. That would have been cleaner if we got it one shot, but that's okay. Demonstrating how to recover from a mistake, right?
Yeah.
Okay. So, any other ones besides that one?
I don't want to monopolize the whole thing. Is it just you and I?
There's no one else on right now. No.
Okay.
I think switching the time kind of befuddled a few people. I apologize for that, but a friend of mine came into town. It's his birthday. I'm going to go hang out with him. So
there you go.
Yeah.
Have fun.
Yeah.
I was getting a little bit confused with, it's another you try.
Okay.
But we can do one that is not one for homework. It's on page 68. It's number 17. It's composition of functions.
Yeah, we could do this one. Let's go ahead and do this one. That's not a problem. Let's do this. I'm going to go ahead and just grab this bad boy and drag it over to the whiteboard. Okay. So what they want us to do is evaluate each of the following, right?
Yep.
Okay, cool. All right, so the thing to remember about composition of functions, a good way of thinking about it is that what you're doing is you've got two machines. You've got an A machine and you got a B machine. So here's your A machine, right?
Mm-hmm.
And then here's your B machine. And so what you do is you take and you put into the A machine, you put an X into it. So you feed in an X into this machine. So a number, right?
Yep.
And what comes out of that machine is an A of X. So you can think about it this way. You can think about like if this was the Hershey's chocolate plant and this was the Reese's peanut butter cup machine, you put in chocolate and peanut butter, right?
Right. And then
And
you get out a Reese's.
you get out a Reese's. Now,
Mhm.
you're not going to walk into your local Chevron station and just buy an unwrapped Reese's off of the counter, now are you?
No.
You want it wrapped, don't you, right?
Mm-hmm.
Okay, so there's a second machine. That's the wrapping machine,
It.
right? So now those Reese's peanut butter cups go into the B machine, right?
Mm-hmm.
And they get wrapped up by B, and so they come out being B of A of X, right?
Hmm.
Is that making sense?
Yeah.
Okay, so that's what that notation means. When they say B of A of X, they're saying, hey, you know, put X into the A machine first, put your chocolate and peanut butter in, make a Reese's peanut butter cup, and then when that spits it out, put it in the next machine and let it do its thing to it, okay?
Okay.
All right, so let's go take a look at that. So since we just did B of X, we'll start off with that one. So B of A of X, the easiest way in my mind to do this is to take it kind of in small steps, is you know that A of X is this. It's 2x minus 1, isn't it, right?
Yep.
So this A of X right here is going to get replaced with 2x plus 1. So it's B of 2x plus 1. In other words, take whatever the definition of A is, dump that out, dump the A out, and put that definition in its place.
In it. Okay.
And so now this is very much like a problem from lesson 1. In other words, they're asking you to do function evaluation at not a constant, but at a function. So the way to think about this is that every place an x resides in the b function, I'm going to replace that with 2x plus 1. So this is going to be 3 times 2x plus 1 minus 5.
Okay, so what did you say about the X in the B?
Okay, let's do a number one first. Put this on the back burner for a minute. Turn it on sim.
Okay.
All right. Let's go play with just b for a moment. What would b of 2 be equal to? Well, every place I find an x, I'm going to replace it with a 2.
The 2.
So, and remember, when you dump the letter, you replace it with parentheses. Okay.
Yep.
So that'll be a 2 right there. Minus 5. It would be equal to 6 minus 5, which would be 1, wouldn't it? Right. Okay. What would b of 7 be?
21 minus 5.
Yeah.
16.
Be 3 times 7 minus 5, which is 21 minus 5, which is what, 16? Is that what that comes out to be?
Mm-hmm.
Okay. What would b of a be equal to?
3a minus 5.
Yeah, good job. Okay. What would b of a plus 1 be equal to?
3 parentheses a plus 1 minus 5.
Sweet. Okay. What would b of 2x plus 1 be equal to?
3 parentheses 2x plus 1 minus 5. Okay.
The light bulb does go on.
Okay.
I drug you into it. You didn't even know you're going there, did you? Tricked you right into it.
You did.
You get it, though? Is it making sense?
Yeah, thank you.
Okay, all right. So now we're not done. You got to distribute this 3, and you get what? You get 6x plus 3 minus 5, right?
Yes.
Yeah, we have to simplify. We got to do the algebra here, which ends up being what? 6x minus 2. That's the final answer.
Okay, it's not that difficult.
No, but you got to understand, believe me, what I just did over here with you,
Mm-hmm.
when I do that in class with people, I got probably over half of the class having the exact same aha moment you did, okay? It is really difficult to see the first time, but once you get it and the light, you burn that pathway, you go, well, duh, that makes total sense.
Yeah.
Andy, there are only 2 flavors of math, trivial and impossible. Once you get it, it's like, well, of course, right?
Yeah.
Before that, it's like bloody impossible. I have no idea what you're talking about. So,
yeah.
So your job is to make the impossible trivial, and you can do it. All right, let's do this one. Let's go through it, okay? So you walk me through it this time. So tell me, what should I do in the first move here? What am I doing?
I guess you should keep the A, get rid of the B, and then
Okay.
put 3x minus 5.
Where the B was.
Yeah.
I like it. Cool.
Okay. And then nothing else?
Well, we got to keep going.
Well, no, I meant.
Oh yeah, no, nothing else at this
Okay.
point. Yeah,
Yeah.
nothing else at this point. Yeah, this is function notation. Don't distribute the A. That's different. Okay, so now what?
B x and then x equals a 3x minus 5. So then we have to put in the a now. Okay, so then 2 in parentheses 3x minus 5 plus 1.
Ta-da! Woohoo! And the crowd goes crazy.
Yay! 6x minus 10 plus 1. 6x minus 9.
Mm-hmm. Okay, now here's the deal. You don't reinvent the wheel. Hang on a second, I think I just locked up. 1 second, wait. There, I'm back. Am I back?
Yep.
Okay, cool. All right. Don't reinvent the wheel. The part that they made you do, when you went up here and actually figured out what a of b of x is, a of b of 4 is going to be equal to 6 times 4 minus 9. This function right here is a of b of x.
A of b of 4.
Right. You just, now all you do is whatever comes in here, you just put it in right there because you know what the definition is. You've built that function now. So that's going to be 24 minus 9.
6, 4 minus 9, 24 minus 9, 13. Okay.
That's good?
Yes.
Is it 13 or 15? It's 15, isn't it?
Nope. Is it 24 minus 9?
I don't know. I did a bunch of manual labor today. My brain is toasted, but I'm cooking in the sun all day.
Yeah, 15. You're right.
Okay, good. All right. So I can still do some arithmetic.
I just did it in my head, so. I did a lot of work today.
Cool. It's a good day to get it done, right? Okay, so the same thing here. Look, b of a of x, this function is 6x minus 2. So don't reinvent the wheel here. B of a of 4 is going to be 6 times 4 minus 2.
22.
Now look, just as for a matter of completeness, just to do this on your own, you should go back and check this just to make sure and go think about it through the whole composition. So a of b of 4 would be a of, and I got to go evaluate b at 4, so that'd be 3 times 4 minus 5. And then once I figured out what that number is, which is 12 minus 5, well, 12 minus 5 would be what, 7, right?
Yep.
Okay, so that would say now go find out what a of 7 is equal to. And a of 7, well, let's see, a of 7 would be equal to 2 times 7 plus 1, which is 14 plus 1, which is 15.
3.
Which way you think was easier?
The first one?
Yeah, so that's what they're trying to get you to see, that it's well worth your time to do the composition, and then you've got that function, you can use it when you need it.
7 plus 1.
Composition is a little chewy, Andy, so don't if you don't get it the first time, just don't give up, okay?
Okay.
Just keep
I won't.
Just keep at it, and eventually the light bulbs will go on like it did over here.
I've been working on it.
Yeah, well, I believe you. I totally believe you. It just sometimes it takes a bit to get it. It did not make sense to me very much the first time I saw it. It took a couple tries, and then when I finally slowed down, it did things like this. I actually would make myself do this, what we did over here, sometimes, just to get my brain back in the right spot, so I could remember what the heck I was doing.
Do it, yeah. I just don't get why when you're plugging in the second part of it, the second step, why the x goes away. So for instance, the 2 parentheses 3x minus 5 plus 1.
Yes.
For the 2 plus 1, how come we didn't need to put the x back in? And then the same thing for the other one on the second one.
You mean on these
Is that
guys
making sense?
or
Like
these
my
guys?
question to you?
Yeah, which one am I working on? This one? Or
The ones on top.
the one on top?
The-
Okay.
Yeah.
What you did is you went in and you just substituted in b of x, put in its definition. In other words, what I put in here was what b of x is made of. Here, let me get a fresh sheet and do it in color, and so maybe that might help. Okay.
Okay.
All right. So we've got a of x is equal to 2x plus 1. Get rid of some of these sheets here.
A lot of work.
That's all right. 2x plus 1, and then b of x, what was b of x equal to? Let's do it this way, it'll be faster. B of x, okay, maybe it's not going to be faster. Let's see.
3x minus 5.
3x minus 5, okay. Okay, so a of b of x. Let's do a little bit of color coding here. So let's say that b of x, let's do that, come on, in red. So b of x is equal to 3x minus 5. So what that means is this thing right here in this red box is 3x minus 5, is it not? Okay, so
Right.
that says take, I don't know why my pen's got this delay and it's killing me. So that's a of 3x minus 5. Okay.
Mm-hmm.
All right, cool. Now we got to go back to what we did a few minutes ago. Think about it this way. Okay, so what would a of 2 be equal? A of 2 would be 2 times 2 plus 1, right? Which would be 5, right? What would a of m be equal to, let's say? Well, that would be 2 times m plus 1, wouldn't it, right? What
Yeah.
would a of m plus 3 be equal to? Well, that would be equal to 2 times m plus 3 plus 1. Well, what would a of 3x minus 5 be equal to? Well, that's going to be equal to 2 times 3x minus 5 plus 1.
Yeah.
Okay, so that's where the x is going. It's following along, but it's coming in through by its definition of what the previous function was.
Okay.
And so now that's where you're going to get the 6x minus 10. That's just using the distributive property. And that's going to get you 6x minus 9.
Yeah.
Okay?
Yep.
All right. The more you do it, the easier it gets.
Yeah. I got
So-
homework to do. So.
Yeah. Well, a couple people in last assignment, I didn't assign all of the practice problems.
Mhm.
Some folks did them anyway, did all of them just to help them get the ideas cemented. So
Right.
you can always look at the assignment of what I consider the minimum amount you need for competency, and you can always do more, all right? Don't be shy
Yeah.
about picking up the rest of them. And any of them that you don't get, whether I signed them or not, they're fair game to put up in the Q&A forum, or you can message me directly and say, hey, can you do this one for me?
Okay.
All right?
All right. That sounds good.
Okay.
Yep.
I think we're good there. I'm going to go ahead and let you go have a Thursday evening with your kids.
Yep. Have fun with your birthday party.
I am. I'm going to go have a beer.
Nice.
I know.
I'm going to have one too.
Good for you. Well, it's a warm
Yeah.
Thursday night. Got to take advantage of it, right?
Yeah, exactly. It's hot. I live in Gasky, so it's pretty hot right
I
now.
was going to say, it is definitely warm up there. Cool.
Yeah.
Hey, the other thing, I had a couple of people tell me the NepTutor is working out really well for them. So
I tried it the first week, and maybe I didn't input my information correctly,
Mhm.
but they came back and asked me more questions, so we kind of went back and forth. So it is, I have been using it. So
okay. Well, let me
That's
know.
been-
I'm curious about your feedback because I'm not getting a lot of students that are using it, and it's not cheap. So if we're
well, it's for me, it's kind of hard because I don't really know how to type up the questions to them. So that might be on me.
well, you know what you can do. What you can always do is you can always scan them in Or you can always hold them up to your camera.
On
They have
on the
cameras.
next.
right?
Oh, I don't know.
Right.
I didn't even see that as an option.
I'm not sure. You have to take a look and see if they have a. I thought that they had a. Or you could do a camera. Well, if not, do they have a whiteboard you can share like we do?
I didn't get that much into it,
Okay.
so I don't know.
Okay. We'll give it another go
Yeah, I will.
and let me know what you think. Okay. I'd be curious to see what you think about it.
Okay, sounds good.
Okay. I'm going to see if Marie, I'm going to unmute her and let Marie see if she's got a question for me.
Okay.
Hi, Marie. What's up?
I had a question about one of the ones that, I left my thing inside, but it was like f of g and f of x,
Like
or whatever.
A of B of X?
Yeah, something like that, and it gave you the input of 2, and then the answer was 11, but on the other chart there was no 11. So let me see where it is.
Was it like problem 18 from the media example?
Yeah, I think it was just like that, but it was 16A or something. It had an A in it because
In the practice problems.
yeah, because there was no answer to it. So
Probably, yeah.
I had it written down somewhere, but I lost my Post-it now. Let me go grab my Post-it.
Okay. And have you started the practice problems yet?
Yeah,
Go with. Nope.
but I don't know what one she's talking about.
Okay. Oh, here we go, 16. This one with the tables. So Marie, can you see my table, my book?
Yes. Yeah, so on 16A, it's G of 2, and then it gives you the output of 11, but there's nowhere to put 11 in F. So I just put no solution.
Okay, so let me go take a look. Hang on a second. I'm gonna grab this thing and move it over to the whiteboard because I'm having an easier.
What page is that on?
Hang on just a sec. Let's see. It is 83.
Thank you. I didn't do that one.
Okay, well, hang on. We'll do it together. All right, let me just kill this one. Let's use the screen. All right. Okay, let's take a look at this one, Marie. So we got, on part A here, we got f of g of 2. So g of 2 is equal to 11. So this is f of 11. And so we come back up here to the x's, and there is no 11 here. So this does not exist. Because f's not defined at that value.
Right. And then on 73, I had a question. Let's see.
73?
Yeah.
Page 73?
Oh,
You don't mean
yes.
problem 73 because I don't think.
No, on page 73, you
All right,
do
wait, hang
the
on.
exponent.
I got to get back there. Let me get back there.
Okay.
Here we go. Yes, number 2.
On B, yeah. GX, FX, F negative 3. No, that's not my page. It's practice problems.
Oh,
page
74.
15.
There we go. 74. Here we go. 73. Okay, my bad. There we go.
Okay, so on B, it's basically I just wanted to make sure I had it right. I do the exponent inside of the parentheses before I clear the
Yes,
parentheses, right?
Exactly. Exactly.
Okay. And then on D, on 74, I had a question too.
Okay. Okay, so what was the question on D on 74?
So when you plug in those functions, you get x squared minus 9 over 2x minus 4. We haven't been factoring them,
You-
although that
you-
wouldn't
you-
even matter here.
Yep, it does. It
just-
still would be. It's still reduced. You could factor that as to x plus 3 times x minus 3, and 2 times the quantity of x minus 2. But you'd find there's no common factors between the numerator and denominator anyway, so it's in reduced form, so you don't have to go any further.
It's just done. Okay.
Yep.
That's kind of what I thought. I'm like, well, I don't think there's anything else to do with it.
Nope, not until we get into that chapter. It's coming,
Okay.
but it's near the end of the course.
Okay. I feel like there might have been one more, but it didn't make it onto my sticky note. So I guess that's everything.
Okay. Well, if you find it, don't be shy about posting me a question to either in the message or to the Q&A form, okay?
Oh, I know one more. On the Desmos activity,
Mhm.
only there. How many people are in those groups that we're working with? Like 4?
Should be 4, yeah.
So if I've only got 2 other answers there, I totally missed going back last week and like responding to anybody.
You can just pick, I'm happy at this point if you guys respond to one person.
Okay.
The main thing I really
There was,
want more
like-
than anything else is I want you to read the other people's responses.
Okay. All right. Perfect. And
Okay.
I think that's everything I had.
Okay.
Thank you.
You are welcome. All
Have
right,
a
you
good
guys.
party.
I'm going to go have a beer on you guys. Okay, so I'm going to call that good. I'm going to go ahead and shut off the recording.